Okay, we are here with hopefully the final video in this project of basically how to make this basic geometry. So last time I left you guys, we had just fixed this issue of how many cuts that we need to make in general. I'm going to go through and talk to you about how to create another shape. In our case, it's going to be a square or a smaller box. And then how to start intersecting, and then we're going to do some basic stuff where we join curves and we extrude them. So our original shape is this. With the Aqua Tower, you can look at that project and see that the original base shape is a square, and then you use this kind of more curvilinear topography thing to make the balconies. Mine is doing the opposite, just because why not? Where I'm starting with the original base shape being curvy, but all my balconies are square. So maybe I want to have some kind of crazy form hidden a little bit amongst an urban landscape so that when you're on the outside, you will, or far away, it blends in with an urban scape. And then when you get close to it, you start to notice that there's something different about it. Structurally, this is probably harder to do than the Aqua Tower, but they serve different purposes. There's different reasons to do those types of geometry. So we had talked about making a bounding box before, and actually we're going to do the same thing. So I have the shape coming up into a relay. Relays are just ways that you can kind of control your wires. If you start disliking where stuff comes from, or if you just want a really generic thing to plug things into, if you say copy and paste this into another program, you can double click on a line and it basically just, your input and your output are the same. And you can kind of move it around and organize things. They're also useful if you need to take a piece of geometry and then apply it to multiple things somewhere else. So in one of my disabled things down here, you'll notice that I have one of the shapes coming here and it's being applied to multiple things. But I didn't want to run two wires the whole way. I just wanted to run the one and then pull that information out. But that's generally, if you see this little Dr. Mario pill shape thing, that's what that is. So I don't need another one. I'm going to get rid of it. So yeah, this is the same bounding box, same thing that we did here. What I'm doing here is I am trying to say I want this box to be essentially as tall as the same building. Like it doesn't make sense for it to get smaller. But I want to have it smaller in the X and Y direction, just so it creeps in a little bit. In our case, all that we have to do for this is, in our case, there's a couple of analysis tools, like this volume here, once again, Control and Alt to find out where something is on surface and analysis. There's also an area one. I don't actually care what the volume is, like it's, some 8 million of whatever unit we're doing. That's not important to me. What it does do is it gives me a centroid. What is the center of this thing? So I want to base whatever transformation I'm doing to this box off of the center of where this box is, which is generally what we would consider the center of this shape. If you plug this volume definition into and actually we'll just do that right now. We'll make another one of these and we'll take this shape and we will see what the difference is between these two. So the centroid is going to be a point. So in our case, that point is 0, or it's 59 whatever by -8 by 125. And if we plug this one in, it is the same, almost the same thing. So you'll notice that the 125 is the same. That's going to be the edges of that bounding box. But because that shape is, there's just more volume in the box than there is in this surface that we saw earlier, that these X and Y's change a little bit. So I'm doing my transformation of the box. I want this centroid to be here. I also want it here because if I apply this somewhere else. I always want it to be based on the bounding box and not the other geometry in case something's really funky. But there is a difference between when you decide to use this component. Anyway, we just want the centroid. And then we want to scale things. So just like you scale things in any other program, you're going to have to say what you're scaling, which is going to be your geometry. You're going to have to say where you're starting from. In our case, there's an origin point, and then there's a base plane. We care more about the origin point, but if your plane does go in a different direction, it will kind of change how your X, Y, and Z work. In our case, if we just give it a normal point, it's going to assume we're using the world's XYZ or XY plane, which is that Z001 part in the yellow box here. And then we have an X, Y, and Z. So we can plug any number into any of these. So if we wanted it to be twice as big, we would plug in 2 into one of these. If we only wanted it to stretch in the X direction, to scale only in one dimension, which is a command in Rhino, scale 1D, we'd only put it in 2. If we want to scale in 2 dimensions, which is what we're doing, we would put it in X and Y, or X and Z if we wanted to scale the Z dimension. And if we wanted to scale all 3, we would have it go everywhere. This tool, Scale NU, is actually just a more complicated version of the normal scale tool, where you get the center, which is essentially this point. So G and C is the same as G and P, and you get a scale factor, and that's going to be X, Y, and Z altogether. The outputs are going to be the same. You're going to get the geometry, and then you're going to get the transformation data. In this case, the factor is already set to 1/2. In our case, it is saying scale 2D, XY 0.8, which is essentially how you would put that in Rhino. But we just simply do that to make sure that our bounding box is a little bit smaller than our normal object. So just by seeing these, we can see what that relationship between the balconies and the actual floor size is going to be. So we've got both of those. And then we do have our cuts of these shapes. So this one you'll see is coming from the bounding box. This is the BREP. So the geometry is a BREP. Boundary representation is what that means. We'll talk about that a little bit more later too. And then in this case, the BREP comes all the way from the surface. So just like we'd organize here, where this is kind of below this one, this shape is below this one. So we've got our lines, and we've got our shapes. One of the other tools that we can use now is called this kind of trim with BREP. What we're basically doing is we're looking to see what lines are inside of a shape and what lines are outside of shape. So the reason we're using this tool is because it's a little bit faster to create from lines and it's to mess with surfaces and extra breps. But it also, we have all of the parameters that we've already have. So we have the curves. That's what's coming out of these. And we have the breps. That's what we use to make the curves in the first place. So in our circumstance, we are going to be looking at, this top one is going to be looking at the BREP, the box, since it's coming from above, and then the curves that we're using from the thing on the bottom, so the surface. And you'll notice that there is a curve inside and a curve outside. So if I create a little curve tool, I can plug it into here, and you can see that it has found the things that are, in this case, inside, like from the box, that are inside the curves that are inside that box. So, and let me change my visibility real quick here so that this is not. Your visibility changes for how things look in Grasshopper and Rhino are going to be here. I tend to use this kind of lighter blue color a lot of the time, just because I don't like the red and green. But So you see that there's this curve here and that this box, if we rotate up and around, you'll notice that it does cut right at that edge. If I do this curve outside of it, you'll notice that it's all the ones that are outside of it. So just switching between these, you can kind of see how that transformation works. That's also, now that we know how to flip between these, we could do it just like the Aqua Tower if we wanted to by changing our inputs here. Or whatever, using the curve outside instead of the curve inside. Similarly, we wanted all of these box portions that are outside of that surface. So you can kind of see it cut it. It's almost easier to see since we have the reference curves there. And then what we finally want to do is we want to join these curves. And there's a tool to do just that. So this is giving us those balconies and nothing else. It doesn't have like extra geometry on the inside. Again, if we flip this around, we will get the different type of geometry, which is more Aqua Tower-esque. So that's the quick and easy of how to use this trim width prep. From here, we can just simply create a surface if we want to, and then extrude it. I was doing the surfaces to make sure I was doing things quicker, but you can also just extrude your curves. And in our case, this isn't solid. If you extrude a surface, it will be solid. But you could do just the same as what I'm doing up here, where I extrude the curves instead, and then I cap them. And that would give you a solid at the end of it. There's a couple ways to do that. So the one thing to point here is that there is this little zipper tool. It's hard to tell the zipper unless you zoom in real close. Let's look at a panel to see, and you can just use the quote mark in order to make a panel real quick as a shortcut. So I've got curves coming out of here, and you'll notice that I have like 4 curves, but then I have like these 5 numbers here. So these are subsets of lists. If we were to continue to go backwards here, that's 4 lists. This array is 3 lists, etc. So each time we're making this, some components are going to add more lists onto here. This zipper tool is called Simplify. You can do this by right-clicking on a component, and you'll see you get a couple of other list tools that are very useful. Simplify will probably be the one you will use the most initially. And you can do that, and what it will do is, while these curves were in these different lists, now they're just smushed down to the same list. We have to do this for this because the curves that are coming off of the box have not had to go through as many transformations. So they only have 2, while these have 5. So if I don't simplify here, things start to break. See, as there are different sets of lists here, some things are not adding together, some things are. So like line-like curves are now together. Basically our things don't match quite right. So we're just doing simplify. We will talk more about how data structures and data trees tend to, and actually, this is also originally why I did the curve tool here. So I could just simplify on the curve tool and not have to worry about if I'm using the inside or the outside. But that is a very common error that, especially starting out, if you don't know how data structures work, you will run into. We'll talk about that a little bit more in person in class, but we will address it more in the next project because the next project is all about how list structures work. Actually, the next 2 projects generally are. So anyway, that's a quick overview of how this works. Hopefully by now you can start to see that just manipulating the simple geometry can lead you to a lot of different places. you probably will want to do some element of experimentation here. This is kind of the base level. This is, if you get done with the project and you've done this, this is like the C range generally. Making things more robust so that they don't break easily will make your projects better, hence why your grade will be better. If they do break, if I change a lot of the parameters, then you're going to want to both tell me what those limits and what things, where does this kind of type of function break, but then also take another step further. What else do you need here? Maybe you need railing, so you need to pull your outside curves here and bring them upwards. Maybe you need to create openings at each of those locations. So maybe you don't want a total solid. Maybe you only want walls. Maybe you want to do... We're going to initialize this. My computer's going to freak out a little bit. Maybe you want that instead of it being totally curvy, you want... I've done some of these things here. You want straight panels. Let me reset this real quick just to make this solid. Say you're doing mullions, you're actually doing a storefront. Those types of things. Take it another step to get it to be more building-like. Once you have the base geometry, you can start doing things much more quickly and applying them to see if they work, if they're really applicable. Or you can make them more robust so that you can have, instead of having, I have these 2 iterations, I have 20 of them, and it works for all of them, and some of these are radically different. They become good argumentation tools in addition to being good exploration tools for you. So I hope that helps, and let me know if you have any questions. I will talk to you guys later.